All right, today we have a bit of an old one. We have a 2013 or 2014 A1502 that does not turn on after a liquid spill. So someone else has already tried to work on this before us, so this might be a little interesting. But first thing we do is plug it in. Now, on all of the MagSafe machines, I don't use an amp meter. I don't use my power supply because I've seen it cause issues. Just use a genuine MagSafe 2. In this case, I'm using a MagSafe 1 with a adapter, which is fine on 2014, but on 2015, you're going to have some issues. So I get no light in the charger. No light in the charger means our one-wire circuit is not working. PP3V42. Okay, so now we have a light. It magically decided to give us a light, so it's hard to see, but we have an orange light. Any of the MagSafe 2 machines, orange light does not matter. On the MagSafe 1s, it did mean it was charging or not. MagSafe 2s always go orange. So, with the bottom cover off, we're going to check some voltages. So very first off, just hit the power button a couple times, see if it turns on. And I get a initial fan spin. The 2015 model will not fan spin. The 2014 will. And this is something called quarter fan spin. I don't know if you can see, but the fan spun, stop, spun, stop. You can kind of see it there spinning. So this is quarter fan spin. At this point, I'm not even going to bother poking around. We've got to pull the board out. So I'm going to get this board out and we'll be right back. All right, got our board out, and boy, do I wish all the new machines were as easy as this. This is a blast from the past. This board is so easy to take out. Wish all the new ones were like that. Okay, now this board has been Q-tipped and alcoholed, so we want to look really closely to see anything. Okay, there's been some soldering attempts here. Yeah, there's been some attempt to do something there. That resistor looks off. There's some flux residue. And quarter fan spin is always really important to look around the BIOS and clock chips. This is our SMC reset circuit. Looks like they might have tried to do something here. It's always really hard to tell. Clock chip looks okay for the most part, and it's always really hard to tell when a board has been messed with prior. I will say that much. So at a minimum, I'm going to take care of this. This little resistor right here does not look too good, as you can see there. I'm going to grab some Citraflow. This just came off the production line today, so you cannot get any fresher flux than this. And we're going to give this resistor a little touch up. So, is this resistor part of the problem? Probably not. Could it be? Maybe, but I really doubt it's causing any issues here. But still, I'm not going to leave this like this. Give the ISL a little bit too. I want to touch up these joints here just to make sure they're good to go. Give it a little reflow. Sure, it's nice and pretty. That's good to go. Quarter fan spin, also U1950 area. And it looks like there was corrosion here, and as you can see, there is more areas that have been messed with. So something, I don't think that was a component there, I think it was just knocked around. But quarter fan spin can be some random knocked off capacitor or resistor somewhere. So we just want to look really closely and see. We just want to be thorough here. So is there anything here that I'm worried about? Not really. Just to put it in perspective, CPU V-core area looks all right. 3.3 volt and 5 volt looks fine. Yeah, it looks like I said, there's been some past corrosion here. What about on this side? BDS area looks like it was hit but cleaned. 3V42 area. Inrush area has some corrosion, but again, that's pretty minor. Nothing looks really too terrible. Aha, CPU V-core area. But again, it does not look too terrible. It's just, there's some corrosion there that will be addressed in the ultrasonic cleaner. It's not a big deal. Oh, hello. It's been a while, my friend. Little JTAG connector. Been a while since I had one of these. But let's just go ahead and, I just want to show you what the board is doing. So with it plugged in, there's our fan. So spin, stop. And that's it. Spin, stop. Doesn't do anything more than that. So it's basically trying to turn on, sees a problem, says, nope, I'm shutting off. So we're going to rip this JTAG connector off because these things are, beyond the initial programming of the board, really not useful. I mean, there's some oddball excuses used to leave it there if you're doing some BIOS hacking or something like that. But in this case, for a repair, we're going to remove it. If someone is skilled enough to want to plug something into that connector to reprogram their BIOS, they're probably skilled enough to solder a new connector on. So we are just going to remove this, forget about it, and call it a day and see if our board works. So thank you. Whatever board engineer decided it was a great idea to put these on the edge of the boards on the 2013 through 2017 machines, thank you. I really, really appreciate that. But then you moved it, so I'm a little sour about that. Just touch up these joints a little bit. That's about it. And now, I bet we get a nice fan spin. Nope, same thing. So we got to dig a little bit deeper. Okay, now it's worth noting where the previous rework was. So that is the current one of the current sensing resistors for our ISL 6259 battery charge controller, which also outputs PP bus G3 hot. So somebody was there doing something. What they were doing, I have no idea. We know they tried to solder a resistor. We don't know why. Is the resistor blown? I don't know, but we're going to check. So the first things first, let's measure what PP bus G3 hot is. I'm going to check just on where I know it is. Shows up right here. And I have 12.6 volts, which is right in spec, pretty much. So is that resistor a problem? Probably not. I wouldn't think it to be. But I noticed something pretty interesting. And that is right around this resistor. There's almost a crater right here. There's like it's almost like it burned. So I want to actually check what our resistance is. It should be 20 ohms on one of them and 3 ohms on another. It's honestly been so long since I've worked on this generation of board. And I have around, 500,000 ohms. That is not good. Let's check our other series here. And I have 20 ohms, so that's normal. And on this one, we have, it's no good, just put it that way. So I'm going to not only replace the resistors here, I'm going to replace both these resistors, I'm also going to replace the ISL 6259. The ISL 6259 can cause quarter fan spin sometimes, and in this case I suspect the ISL 6259 might have shorted, or somebody messing around in the area had caused this whole problem. We don't know, we're just going to get rid of it. And interestingly enough, our board was still outputting the right voltage. Kind of a mystery there. That doesn't make sense, but maybe it'll make sense after we dig further into this problem. Come on, ISL. Here we go. Just going to replace this like I do every other QFN chip now. I reuse the solder unless it's corroded. Some flux down. Some flux down. And let's grab an ISL 6259. This drawer has not been opened in a while. And these are not ISL 6259s in the ISL 6259 drawer. Imagine that. Again, it's been a while. Here's some. I remember when COVID hit, I stocked up on this chip. I bought so many of them and have a surplus now because stopped seeing them. I don't know if people just got new computers or what, but we stopped seeing a lot of these older boards. They're a rarity nowadays. Come on. Based on how this chip sits, I kind of think it's been replaced before. It's hard to say. We can't really say, honestly, so switch to my BC2, BC1. A little more flux around here. Looks good. Now this area right here. Yeah, this burned. As you can see there, that does not look too hot. So this pad is fine. This one is gone, so we're gonna need to run a wire. Yeah, that is toast. Completely toast. Some flux in there again. And whatever capacitor you can go to. You're probably not in the best condition as it is, so you can go. All right, let's get some new parts. So I'm going to grab a donor board and pull these off. A1502 right here. And it's going to be a challenge to find a board that doesn't have things stolen off of it in that circuit because 1502s, I mean, we saw a lot of them before. Here we go. Used to see a lot of these boards. This was a popular machine, and then that it got replaced with A1708s, which is a inferior machine, in my opinion, to the 1502. More flux. Yeah, I'm really not sure what happened here. if the trace was broken from someone trying to resolder it, which is kind of what I suspect, or if it burned. I don't know. We'll never know. See, there's a little via right here. Yeah, it doesn't look good. But what we're going to do, we're just going to jump that to where it goes to. So I'm going to open up board view right now, and we're going to find out where that goes to, and we're going to run a wire to it. All right, here we go. So here's our resistor right here. It looks like it goes all the way over here to the top pin of R7150. So look at this on the board. Wrong camera. Let me switch back to our microscope. There we go. So top pin right here. Not too bad of a run. Or we could run it to, I kind of like it better to run it to this pin right here. And you could even see where somebody probed there. Somebody was definitely here doing stuff before, and I don't know if they just gave up when they saw that or what. We can just run it to that middle. That's what I'm going to do, actually. It's kind of a cleaner run, in my opinion. So let's get our jumper wire. I'm going to use our big one for this because we're dealing with 402, bigger components. Can never have enough flux, right? Nice big blob in the center. And over here, I'm going to, actually I want to make sure there's coating on this, so I'm going to break off the end. The ends kind of get burnt sometimes, so best to sometimes just leave it off and start fresh. Like so. And we are going to run this over. Remember, this is coated wire, so it's not going to hurt anything. But I kind of want to keep it away from rubbing on components too. So we're going to do our best. We'll coat it a little bit as well. Just like that. Looks pretty good, and you couldn't see what I was doing, of course. Oh yeah, you could. Thought I was out of frame, but it wasn't. That's good to go. And anytime I put the joint under stress like that, I like to give it a little bit of heat. Just to make sure. And sometimes that happens. So sometimes you'll mess up, and that's okay. So it wants to just fly away. We'll grip this, get him back down here. Come on, little guy. Definitely want conformal coat here. Actually, I'm going to redo this. I don't like this wire, and unless I could route it in a different way. Yeah, I don't like that at all. Yeah, I don't like how the coating was kind of stripped back too much. And it was too close to that probe point for my comfort, so I'm not going to risk it. There's that. And kind of wrap it around here. Again, touching something is not going to matter because, like I said, this is going to get conformal coated after. Try and keep this in focus for you guys. There we go. Grab my iron. And work on getting this soldered here. It takes a little minute to get the coating burned off. The coatings on these wires are actually really durable. I know they seem very thin, but the coatings are pretty durable, as you can see here. Sometimes the resistor even ends up falling apart before you can get solder on it. That looks good. Just want to clean that joint up a little bit better. Beautiful. And now we see if our issue is solved. This joint looks really good. There's that. Okay, so kind of think this was our issue, honestly. I've seen quarter fan spin caused by the ISL before. So we will see. So here's our fan. It's just very unusual that PP bus was present, but then again, I've seen it before. So, you know, these older boards are kind of a little special. And there you go. That is a fully spinning fan. It should ramp up to full blast here in a second, because the trackpad's unplugged. See it speeding up. There we go. That is fixed. Let's go ahead and pop this in the enclosure and see if it boots. Okay, these current sensing resistors were indeed from the battery. If we could look at our schematic here, let me pop this up. Back to display capture and pull this over here. These resistors were for our battery. So that explains why, even though the battery was not connected, the ISL saw that that resistor was too high of resistance and it thought there was something pulling a lot of power from the battery when it really was just a blown resistor, hence why it would turn on. We had PP bus present, but it would shut right off. Anyway, we are back in the enclosure, so let's go ahead and see how we're doing. So this is running off the battery, no charger here, and you can see we have a flashing question mark folder here, which is because our SSD is out. We're not going to plug the SSD back in until the board gets ultrasonically cleaned, but you can see here, this is a working, powering on MacBook that is fixed. So a little bit of an older machine, but glad it's working again, and thank you for watching.